I'm going to give a brief demonstration of the operation of the spectroscientific MiniLab 53 oil analyzer. The MiniLab 53 reduces unexpected machinery downtime and maintenance costs by trending machinery oil chemistry, contamination, water content, and machinery wear. This enables data-driven, condition-based maintenance decisions. Fast and easy to use, it's a practical alternative to commercial oil laboratories. The MiniLab 53 answers the questions: is the oil clean? Is it dry and still fit for use? And most importantly, is the machinery still in good condition? To start, select a sample from the AMS database and send it to the instruments. The MiniLab 53 uses a spectroviscometer, which is a 40° C kinematic viscosity. We simply take a single drop of oil, drop it into the viscometer. Parallel plates heated to 40 C give you a direct measurement of kinematic viscosity. Once the viscosity results are displayed, simply push the Save button to transfer the data back into AMS. After each sample, you want to clean the plates in order to prepare for the next sample. No solvents are required to clean the viscometer. A simple non-abrasive cleaning pad is all that's required. We'll now test for water content in the oil chemistry. This is done on the fluid scan and infrared spectrometer. It measures water, total acid, total base, oxidation, nitration, sulfation, and other oil-specific properties. An innovative patent-pending technique for sample preparation for the fluid scan makes it a practical alternative to Carl Fischer titration. The sample is homogenized for 20 seconds and let sit for 1 minute. Homogenization is used because free water is not uniformly distributed in the oil sample, but shows as discrete droplets of water. High-speed homogenization breaks up these droplets and creates a uniform distribution of water in the oil. A few drops of sample are placed on the sample cell, and measuring time is less than 1 minute. Before any oil analysis, it's always a good idea to agitate the sample to uniformly distribute particulate throughout. I'm drawing off the sample to use for the fluid scan. A patent-pending technique homogenizes We let that sample sit for a minute before running it in the fluid scan. In the meantime, we can take the rest of our oil sample, put it in an ultrasound for 30 seconds. That removes any air bubbles introduced during the shaking process. After that's done, we'll take that sample and process it on the LNF particle counter and Ferris monitor. The fluid scan infrared spectrometer measures water content and oil chemistry. Parameters such as total acid number, total base number, oxidation, nitration, sulfation, as well as other oil-specific properties are measured. A single drop of oil is placed in the flip-top cell. The cell is closed, inserted into the spectrometer, and then the sample run. The LNF can process undiluted oil samples up to 320 centistokes viscosity. If heavier oils are processed, they must be diluted. If dilution is used, it's very important to filter the solvent used for dilution, otherwise they can contribute errors to the particle count itself. There's many commercially available ways of filtering solvent. One we offer is a standard accessory, solvent filtration. The container is simply filled with solvent, pressurized with a hand pump, And then when it's released, the solvent is pushed through a very fine filter, a 0.8 micron filter, which takes out all particulate below a micron. So that aside, we also offer in the standard accessories and the consumables kit, consumables that are used to prepare the solvent with dilution. So in this case, the approach would be, if you're using dilution with the sample, the straightforward way to do it after you've shaken the sample to disperse finally the particulates is decant to the second line of the bottle, and then take a syringe with 10 cc's of solvent, such as lamp oil. You can use kerosene, lamp oil, electron 22, really any traditional lab solvent to dilute, and inject your 10 cc's. Then once that's done, again, agitate the sample for 30 seconds. Once the 30 seconds has elapsed, place it in the ultrasound, again for 30 seconds, and that will remove the air bubbles. So that is one methodology of preparing a diluted sample for analysis in the LNF. After the ultrasonic, which removes the air bubbles, we process the sample on a particle counter and Ferris monitor. This test measures particle count and Ferris wear on the LNF Q230. The schematic here shows the flow path of the LNF. The sample is drawn up through the tube, through a 100 micron filter that removes large particulates, and enters the force portion of the Ferris monitor, a high sensitivity magnetometer which measures the Ferris particle count. Next, the sample enters the LNF flow cell, which uses laser light and a CCD detector to image each individual particle. This provides particle count and ISO codes, and also characterizes all particles greater than 25 microns into a wear class, either fatigue, sliding, or cutting wear, non-metallic, or fibers, based on the shape of the particles. Finally, the sample enters the second magnetometer, which measures total ferrous content in ppm. The LNF can process undiluted samples up to 320 centistokes. For heavier oils, a simple dilution can be made using the standard MiniLab 53 consumables kit. So, I'm now going to make a measurement on the fluid scan while the LNF is processing. Again, a single drop of oil is what's required. Just close the flip top cell. Start the measurement. Once the sample is processed in the LNF, you flush with solvent. Typically use either electron 22 or lamp oil. Simply select continue from the screen. So the fluid scan results have completed while we were preparing the sample for the LNF.
Unless you have to go in.
Once the results are complete, you simply select save, and again it will transfer data into AMS. So we've completed 2 of the 3 tests. We completed viscosity measurement and the fluid scan, oil chemistry, and water content measurement. The data from the 3 instruments are now recorded into the AMS Machine Health Manager OilView LIMS database. From the database, one can look at sample results.